Basic concept of differential equation.
All right, class. Today we want to start with differential equation. We want to start with differential equation, and today we're looking at just the basic concept of differential equation. The basic concept of differential equation. Okay. Now let's look at. We know this familiar formula, which is force is equal to mass times acceleration due to gravity. When it's force equal to mass times acceleration due to gravity, I believe everyone here knows this formula because it's an universal formula that was established or that was discovered by the scientist Newton. Now, in short, we can say F is equal to what? Ma. Now, if it is acceleration due to gravity, then we can say F is equal to what? Mg. Because the acceleration due to gravity is represented by G. Now, we know that acceleration also is what? Velocity on time. Velocity on time. And from here to, you know that velocity is the same as what? Distance on time. So let's say that a ball goes through, a ball accelerates, a ball with a speed of, let's say 20 meters per second. And let's say the distance here becomes, let's use the letter x as the distance that was covered with the streak. Then we can say here that the difference between the distance, the difference between the 2 points is the distance with respect to a certain particular time. So we can say that the v here becomes what? The derivative of x with respect to what? The derivative of t. The derivative of x with respect to what? The derivative of t. Now, acceleration here is also equal to what? Acceleration there is also equal to v on t. And if v is equal to this, then we can find, when we want to differentiate acceleration. So now, if we want to differentiate acceleration, that is with respect to the v on, differentiating acceleration, the v on what? On the t. Then when you differentiate acceleration, what we'll be getting is that you'll be getting a double integration. That is a higher derivative of what? Of the velocity. So now, if you differentiate distance, you get velocity. If you differentiate the velocity again, you must get, if you integrate the velocity again, you might get acceleration. So it is a higher derivative. I'm getting it. So what I mean is, first of all, you will get like y dx. Secondly, you get the square y over the x. Thirdly, that is a third derivative. You get the cube y over what? Over the x cube. Do you get it? So now at this very point, what we can say is that acceleration a can be equal to what? The cube x over what? The t square. Because we are using x as the distance that was created over here. So that will be d over the t times the velocity. The velocity over here. So d over what? Sorry, that will be d over t times the velocity. So now it's the v over what? Over t. The derivative of the v over what? Of the t. And what is the derivative of the v? The derivative of the v here is what? The x. The v here is what? The x all over what? The t times what? D on what? On t. Because the v here is what? The x over the t. So now when you do this, what are you getting? You are getting what? The square x over what? The t square. And that is what I place here. So that will give what? The acceleration. Okay. Now with this understood, this is just a basic concept. With this understood, if you are considering an upward motion, what happens is that when there is an upward motion, that is when a body is accelerating upwards. What happens is that it goes against gravity. The body goes what? Against gravity. So the acceleration due to gravity is considered as what? Negative g. The acceleration due to gravity is considered as negative g. So with that said, then we can say that our force should be equal to the mass times negative g of the acceleration, which is simply what? F is equal to negative mg. Alright. And now I've already established the fact that F is also equal to ma. So per our differentiation, you can say f is equal to what? M the square x all over what? The t square. So this and this, we can equate them. So now when we equate them, we have m, which is equal to the square x over the t square, equal to minus m on g. Now we can find, our focus is to find the distance. Our focus is to come and find the distance x. Is to come and find the distance x. Right? So now if you get the distance x, that means we have to do a double integration. I get it. We have to do the double what? Integration. So now the first integration will bring us to the first derivative. So now our first integration will be like, okay, let me do it here. We can now bring the m out. We do our double integration of the square x all over the t square is equal to our m out. We do our double integration of what? Negative j, which is negative j. All right. So now, what happens is that when we do this over here, this is with respect to what? The x. This is with respect to the t square. So now, this here is a double integration. And after this double integration, what we're getting is that we'll be getting x as a function of t. X as a function of t, which will be equal to x as a function of t, which will be equal to what? Negative half gt squared plus c1t plus what? c2. Now, when we are done with this double integration, the reason why we are getting the constant c1 and c2 is because it is what? Not a definite integral. It is an indefinite integral. It is an indefinite integral because the arbitrary constant c1 and c2 is needed. And you are c1 and c2 because it is a double what? Integration. You are c1 and c2 because it's what? A double what? Integration. As time goes on, you understand the reason why I jumped from here and I could be able to go there. That is your little differentiation you should know whilst you were in secondary school. So just this is a little basic concept under differentiation. All right. So now when we say a differential equation is an equation that involves one or more derivatives or a differential of unknown function. So anytime you have an equation that particular equation is involving one or more derivatives, then we say this equation is a differential equation. Then this equation is a differential equation. All right. Now, what are the things we should know about differential equation? What are the things we should know about differential equation? Now, with differential equation, there are basically three things you have to know. Every differential equation contains one, a dependent variable. Every differential equation contains a dependent variable. Two, every differential equation contains an independent variable. Every differential equation contains an independent variable. And three, every differential equation contains or might contain some parameters. Every differential equation might contain some parameters. Now, why do I say this? From our normal studies we did in our secondary school or high school, you realize that we always write the y of what? Of the x. When you have an equation of this nature, what happens is that the derivative of the numerator is always the dependent variable. The derivative of the numerator is always the dependent variable. And the derivative of the numerator is always the independent variable. It's always the independent variable. Now, if you have any variable in the equation, in the differential equation, that is not under the influence of a derivation, then that variable is referred to as the parameter. So any variable in the differential equation that is not under the influence of any derivation, then we say that variable is a parameter in the differential equation. So for instance, let's take a differential equation. The square u all on the t square plus the square u all on the x square, which is equal to r squared cos omega t. R squared cos omega t. Now, when you have a differential equation of this nature, and you are asked to find the dependent variables, the independent variables, and the parameters, it is very simple. Anything on the numerator that has the derivative is what? A dependent variable. So from here, the dependent variable here is simply what? U. So U is on the numerator, that is the dependent variable. The independent variables here, there are two. You have the variable t and the variable x as denominators of the derivation. So we have t and x. And now you can have some parameters also in the equation. And these parameters in the equation, we have our r and we have our omega also as parameters of this particular differential equation. Now, how do we classify a differential equation? Now, if you want to classify a differential equation, they are into two. Differential equation can be classified into two. One, we have the ordinary differential equation. And in some books you'll be seeing ODE. And two, we have the partial differential equation. And in some books you'll be seeing what? PDE. Now, what is the difference between this particular equation? Now, when you have a differential equation that has a single independent variable, that particular equation is called ordinary differential equation. If the equation is having a single independent variable, then that equation is called an ordinary differential equation. But if the equation is having two or more independent variables, then the equation is called what? A partial differential equation. So if you have an equation that has a single independent variable, then it's an ordinary differential equation. But it's having two or more variables, it is a partial differential equation. Let's take an example. So now you have an equation of this nature: the square y dx plus maybe the square u all on what? All on the x plus is equal to, let's say, r. Now this equation is only having one independent variable, which is what? X. So we can say this differential equation is an ordinary differential equation. Now, consider this very equation also here. This very equation here is a typical example of what? A partial differential equation. This equation here is a typical example of what? A partial differential equation. Why? Because it is having two independent variables. Alright.